So in this video, I'm going to focus on balancing equations and using state symbols. It's not something that's associated with any one topic in particular. It's something that you're expected to be able to do across all topics. So it is going to be on your paper 1 and your paper 2 exam. I've written the chemical equation for you, and in this video we're just going to practice balancing. If you need help with writing the chemical equations, then I've got a separate video where I go through how to write chemical equations. However, for this video you do need to be able to read these equations. You need to know what elements are present and how many of each element you have. So if I look at what I've written so far, I've got Na. Na is the symbol for sodium, and because there are no numbers around sodium, that tells me that I've just got one sodium on the left hand side. Cl is for chlorine. That number 2 next to chlorine tells me that I have got 2 chlorines on the left hand side. And if I come over to the right, you'll see I've got the same elements present, sodium and chlorine. Sodium, I've just got one sodium. Again, I know that because there are no numbers around sodium. And chlorine, I've just got one chlorine this time because there are no numbers around chlorine. I need to have the same number of each element on both sides. At the moment, you can see that you've got one sodium on the left and one sodium on the right, so that is balanced. But with my chlorines, I've got 2 chlorines on the left and only one on the right, so it is not balanced. If I've got 2 on the left, I need 2 on the right. When you are balancing, you cannot use small numbers. So we use small numbers when we're writing the original formula. So as you can see here, it's Cl with a small number 2. But once the formula has been written and you're going back to balance, you have to use large numbers. So I cannot just put a little 2 here at the end and say that it's balanced. You have to use large numbers, and you have to put the large number at the start of the formula. So even though I want to have just the 2 chlorines and I don't want to change the number of sodiums, I can't just insert a large 2 in between the sodium and the chlorine. It has to go at the very front of the chemical formula. So if I've got 2 chlorines here, the only way to get 2 chlorines on the right is to put a large 2 in front of the NaCl. Now I have the correct number of chlorines on each side, 2 on the left and 2 on the right. But by putting that large 2 there, I have now given myself 2 sodiums on the right, and I currently only have 1 on the left. Again, when I'm balancing, I cannot just use a small number. I have to use a large number, so I'm going to put a big number 2 in front of that sodium. I've now got 2 sodiums on the left and on the right, 2 chlorines on the left and on the right. The next example is similar. I've got K for potassium and Br for bromine. I've got 1 potassium on the left-hand side, and again, I've got 2 bromines, so that Br2 tells me I've got 2 bromines. On the right-hand side, as there are no numbers, I've only got 1 potassium and I've got 1 bromine. So a similar situation to what we had above. The potassium start off balanced, but the bromine, 2 on the left, only 1 on the right. I need to have 2 bromines on the right hand side. I cannot use a small number. I cannot assert a number in the middle of the formula. The only thing I can do is put a large 2 at the front. This now balances my bromines, but by putting that large 2 there, I've now given myself 2 potassiums. I now need 2 potassiums on the left. So again, I cannot use a small number. I use a large number and I put it at the front. I've now got 2 potassiums on each side and I've got 2 bromines on each side. It is balanced. Look at the next example. I've got lithium and oxygen to give me lithium oxide. I've got 1 lithium on the left hand side, but the small number here in my formula tells me I've got 2 lithiums on the right hand side. Oxygen, I've got 2 oxygens on the left, and on the right, because there's no number after oxygen, that tells me I've only got 1 oxygen on the right hand side. So neither element is balanced in this situation. It doesn't matter which element you balance first. You can balance the lithiums first, or you can balance the oxygens. Sometimes you'll need to balance in 2 steps, sometimes you'll get it right in 1. So for example, even though I know it's easier to balance the oxygens first, I'm going to balance the lithiums first just to show you what's going to happen. So I've got 1 lithium on the left hand side, I've got 2 lithiums on the right hand side. I need 2 on the left. The only way to achieve that is to put a big 2 in front of the lithium. Now my lithiums are balanced. When I go to the oxygens, I've got 2 oxygens on the left and only 1 oxygen on the right. That means I'm going to need to put a large 2 at the front. Now I've got 2 oxygens on the left and 2 on the right. But by putting that large 2 on the right, I've now changed the numbers of lithiums. I now have 2 multiplied by 2. I've now got 4 lithiums on the right. I only have 2 on the left, which means I'm going to need to change that 2 4, 4. Okay, so it's fine that you balance the lithiums first and then you go back and you change it. Sometimes you'll need to do a little bit of trial and error. It doesn't actually matter which element you choose to balance first, as long as they all work out fully balanced at the end. So I've got 4 lithiums on each side, I've got 2 oxygens on each side, it is now fully balanced. But look at the next equation, magnesium and chlorine. I've got 1 magnesium on the left, 1 magnesium on the right, that's balanced. And with the chlorines, I've got 2 on the left and 2 on the right. That's already balanced. I don't need to add any large numbers. Some equations will be balanced already. You're not going to need to do anything to them. We look at another example. It's the same idea. I've just got 2 reactants and 2 products, but I'm going to do the same as I did before. I've got 2 chlorines on the left. So I'm just going to write down, I've got 2 chlorines on the left. I've only got 1 chlorine on the right. Okay, there's no numbers around the chlorine, which tells me I've only got 1. With potassium, I've got 1 potassium on the left, and I've got 1 potassium on the right, so that's balanced. My bromine, there's no number next to the bromine, it tells me I've got 1 bromine on the left, but this little number 2 here tells me that I have got 2 bromines on the right. So my chlorines need to be balanced and my bromines need to be balanced. Doesn't matter which one I do first. Here, 2 chlorines on the left, I need 2 on the right. I cannot use a small number, I have to put a big 2 in front. That gives me 2 chlorines on each side. If I now do the bromines, I've got 1 bromine on the left, I've got 2 on the right, so I'm going to insert a 2 on this side. Now I've got 2 bromines on each side. By adding those large 2's, I've changed the number of potassiums. I've now got 2 potassiums on the left, but I also have 2 potassiums on the right, so it is now fully balanced. We'll just do one more together and then I'll get you to try some for yourself. But lithium and water goes to lithium hydroxide and hydrogen gas. I've got 1 lithium on the left and 1 lithium on the right. Again, I can tell that because there's no numbers in my formula. I've got 2 hydrogens on the left and 2 hydrogens on the right. Okay, so I can see that by the small number 2. And then, oh sorry, no, I do not have 2 hydrogens. I've got 2 hydrogens on the left and I've got 1, 2, 3 hydrogens on the right. So I've got 2 hydrogens here in H2, but I've also got a hydrogen in LiOH, so 3 hydrogens in total on the right hand side. And then here I've got 1 oxygen on the left, and here I've got 1 oxygen on the right. So you will see that your lithiums are balanced, your oxygens are balanced, but your hydrogens are not balanced. You've got 2 hydrogens on the left hand side, you've got 3 hydrogens on the right hand side. Now in order to balance this equation, you might have to have a little play around with it. I said I've got 3 hydrogens on the right and only 2 on the left. I need more hydrogens on the left hand side. And the kind of smallest number that I can put in front of the H2O that will increase the number of hydrogens is a 2. So I'm going to start by putting a 2 on that side, which gives me 4 hydrogens now in total. But I've only got 3 on this side, which means I'm going to need to add numbers on the right hand side too. If I put a large 2 in front of the LiOH, then I've now got 4 hydrogens on the left, 2 times 2 is 4, and then 2 times 1 is 2, plus 2 is 4. Okay, I've now balanced my hydrogens. But by putting my 2 there, I've changed the number of lithiums and oxygens, so I need to go back and check that. I've got 2 times 1 is 2 oxygens on the left, and 2 times 1 is 2 oxygens on the right, so that's already balanced. But I've now got 2 lithiums on the right hand side and only 1 lithium on the left, so I need to put a large 2 in front of that lithium. Okay, so this one is slightly harder because you've got more species involved, but if you follow the same process, even if you need a bit of trial and error, you should hopefully be able to get there in the end. I'm going to give you 5 equations to do for yourself, so press pause, balance those 5, and then press play when you are ready to see the answers. Okay, so these are the answers. This is what you should have gotten. They're all similar to the examples that I went through above, so I'm not going to go through them all again. Just please remember to be using large numbers and to double check at the end that you've got the same number of elements on each side. So also said we're going to look at state symbols. State symbols are used to tell you what state something is in. So your states are solid, liquid and gas, and you can also have aqueous, which means it's dissolved in water. If it's a solid, you'll use S, liquid is L, and gas is G, and they're all lowercase. If it's aqueous, if your told means aqueous or it's in solution, that means it's been dissolved in water, and you use the state symbol AQ, and again, that's lowercase. Often in the questions, they'll tell you if it's solid, liquid, or gas, and you just need to put the state symbols in, but there are a few of them that they can expect you to know. So for example, things that you would expect to be solids, metals, okay? Metals are solid at room temperature. So if they give you an equation with sodium or copper or magnesium or just any of the metals in it, they can expect you to just know that metals are solid at room temperature. Ionic compounds are also solid at room temperature. So if you've got a metal and a non-metal, you've got an ionic compound. So sodium chloride, calcium oxide, copper oxide. In each one, you've got a metal and a non-metal, and they are solid at room temperature, okay? With ionic compounds, they can sometimes tell you that they're aqueous, that they've been dissolved in water, but if they don't mention the word aqueous or in solution, then you can assume that your ionic compound is a solid at room temperature. So you've got your metals and you've got ionic compounds. Unless you're told that the ionic compound has been dissolved, you can assume that it's solid and it's going to get the state symbol S. In terms of your liquids, you are supposed to know that water is obviously a liquid at room temperature. The other one you have is bromine. So you do study the group 7 elements and you learn that bromine is a liquid at room temperature. So again, unless they tell you that bromine is in solution, you can write down that it is a liquid. And the other word you need to look out for the state symbol L would be molten. If they tell you something is molten, then you'll use the state symbol L. So sodium chloride, I said, is ionic, so it would typically be a solid. But if they told you you had molten sodium chloride, that means you have melted the sodium chloride, and the state symbol would change from S to L. So look out for that word molten, because it will tell you to use the state symbol L instead of a different state symbol. In terms of when to use G, there's quite a few of these that you are expected to know, okay? You're expected to know that hydrogen is a gas, nitrogen's a gas, oxygen's a gas, carbon dioxide is a gas, okay? They're all quite common. From studying group 7, you should know that fluorine and chlorine are gases at room temperature. When we do equilibrium, we will look at NH3, which is ammonia, in detail, and you do need to know that that's a gas. And then from the fuels topic, CH4, methane, that is also a gas. So often, again, an exam question, they might tell you it's a gas, but they can expect you to know that these guys are gases. The last one will be aqueous. With aqueous, if you've got an acid or an alkali, it's going to be aqueous. So acids are always dissolved in water. So if you've got hydrochloric acid or sulfuric acid or nitric acid, and they tell you you've got an acid, that state symbol is always going to be AQ. The same with an alkali. If they tell you you've got an alkali, lithium hydroxide is an alkali, then you need to know that the state symbol is going to be AQ. The other words you should be looking out for, and they will tell you this in the question, if they say something is in solution, if they say something is dissolved in water, or if they actually say that it's aqueous, then you need to look out for those words in the question, because it will tell you that it is AQ. So if we go back to the equations that we wrote, we can add in some state symbols. So if I look here, I've got lithium and oxygen going to lithium oxide. Lithium is a metal. So unless I'm told, well, I'm not going to be told otherwise with lithium. Unless I'm told otherwise, I'm going to write that lithium is a solid, because metals are solid. Oxygen is a gas, okay, oxygen gas. And when they react, they form lithium oxide. You've got a metal and a non-metal, which is an ionic compound, and ionic compounds are solid. Okay, so unless you're told otherwise about these things, that's the state symbols you're going to use. Similarly, below I've got magnesium as a metal, so it's going to be solid. Chlorine is a gas, and they're forming an ionic compound, which is going to be solid unless you're told otherwise. The next one down here, I've got chlorine. So in this question, they would likely tell you that things were in solution. Okay, they would say that in the question. They'll say you react a solution of chlorine with a solution of sodium bromide, and you form the potassium chloride solution, bromine solution. And when they're using those words solutions, it means that you're going to be using the state symbol AQ across the board. So they're all going to be AQ if you see that word solution. Down here, I've got lithium. Again, I know lithium is a metal, so it's going to be solid. H2O, water. Water is always going to have the state symbol L. Lithium hydroxide, they would tell you in the question that you are forming a solution. Or they could say that you're forming the alkali, LiOH. They'll either say you're forming a solution of LiOH, which will tell you it's AQ, or they could just say you form the alkali LiOH, and you'd be expected to know that an alkali is always going to be aqueous. And then at the end, you've got hydrogen. You're expected to know that hydrogen is a gas. Have a go at filling in the state symbols down here, okay? So in certain cases, I've written the word solution over it, because you'd be likely told that these guys are solutions. So LiOH is a solution, MgCl2 is a solution, and then at the end, you've got all solutions. So if I said solution, it's going to be AQ. Otherwise, you'll need to figure it out for yourself. So have a go with those 5. Fill in the state symbols for each. All right, so if you just run through the answers, magnesium's a metal, it's a solid reacting with a gas, forming something ionic, which is going to be solid. The same for number 2. For number 3, lithium metal is a solid, water is going to be a liquid. I've told you this is solution, so it's AQ. You're expected to know that hydrogen is a gas. Here, magnesium's a metal, it's a solid. This one, HCl. HCl is an acid, so it's going to be an aqueous. All of your acids are always going to be AQ. I told you you're making a solution, so it's going to be AQ, and hydrogen is a gas. At the end, I've told you all of them are solutions, so they're all going to be AQ. So with these questions, more often than not, you're given quite a lot of information. The question, they'll usually tell you, but they can expect you to know the following. So I would learn this. I would learn the kind of gases that you're expected to know are gases. Learn that acids and alkalis are always aqueous. Water, you should know that's a liquid. And learn that metals are always going to be solid unless you're told otherwise. Unless you're told that your metal is molten, then it's going to have the state symbol S. Okay, same with ionic compounds. If it's ionic, it's going to be S unless you're told that it's molten, or unless you're told that it's being dissolved in water. You can assume that an ionic compound is going to be S. So with these questions, it's so important to read the question really, really carefully and underline any kind of hint that they're giving you before you start assigning your state symbols.